All right, we're on to chapter 2.1, basic assumptions. Now, I'm going to talk about some properties. These are properties that you're going to hear come up many times. You actually use some of these properties without even realizing what they are and why you can use them. So, I'm kind of going to give them to you. Okay, so assume that A, B, and C are real numbers. So those are really fractions, decimals, repeating, negative. Honestly, pretty much every number you know is a real number. We'll get to imaginary numbers later on in like algebra 2, but pretty much what you know right now is a real number. Now, so we're assuming A, B, and C are real numbers. So for the following properties, so we have closure properties. So closure properties is A plus B is a unique real number, and also A times B. So that's with the closure property. It's just basically saying that it's a unique real number. And the reason why it says closure properties is because we have two of them. It has the addition and the multiplication. So if you're specifically talking about one, it could be a closure property. Now continue on down. Now these ones you're going to hear a lot. So commutative. Commutative properties. So there's two types, very similar. It involves addition and multiplication. So for the addition, it basically says A plus B equals B plus A. If you think about it, 3 plus 2 is the same as 2 plus 3. Same thing. It doesn't matter which order. So we have, that's for addition. Okay. And then you also have A times B, because you have that imaginary multiplication. It's the same as B times A. So 3 times 2 is the same as 2 times 3. So that's the multiplication one. Okay, so you have the commutative property for addition and commutative property for multiplication. Basically, if you want to think of it, another way to think about it, so basically, it's order doesn't matter. Order doesn't matter, and that's only for those two. Subtraction and division do not work. They do not work for the commutative property. Then we have the associative property. So these are like the very commonly used ones that you don't even realize. Oops. Okay, so the associative property, again, there's an addition one and a multiplication one. So we have A plus B in parentheses plus C equals A plus B plus C. So it's basically saying if you did added the first two first and then you added the third one, that's the same as adding this last two first and then adding the first one. And that one's for addition if you can't tell. And then we have the same one for multiplication. So it's basically A times B, then you multiply times C. It's the same as A times B, C in that parentheses. So again, you could do the first two, multiply those, and then multiply the last one, or you can multiply the last two and then do the first one. Again, they're the same thing. You're going to get the same answer. And this is only for addition and multiplication. So for this one, you basically can say you can group any way you want. There we go. So, know those. Those come up a lot. I'll mention them a lot in class. Okay, properties of equality. So we have some properties of equality: reflexive, symmetric, and transitive. So, reflexive is basically saying A equals A. It's a reflection. It's the exact same thing. 3 equals 3. 2 equals 2. Simple enough. Symmetric, similar, but it's basically saying if A equals B, then B equals A. That's kind of like if I were to ever say, let me write a little example right here. If I were to say 2 equals x plus 1, I can write it as x plus 1 equals 2. It doesn't matter if you flip-flop them, which side it's on, so you can interchangeably switch them. Okay, same thing. Transitive is basically saying if A equals B and B equals C, then that means that A has to equal C. Okay, because if B is already equal to both of them, then why wouldn't they be equal to each other? So so those are the ones, the properties of equality: reflexive, symmetric, transitive. Now we got our example problem. So it says we use one of your properties to make it easier. Some of them, some of them are easier, like you can use multiple properties. So honestly, I'm going to switch these two because if I threw them in my head, you'll see. Okay, so basically I'm going to say 11 plus 9 plus 5 plus 15. So I switched those two, so I used what property? I used commutative. Okay, so I could switch those because now, and then if I group them with associative, I know that that's 20, and I know that that's 20, so I used associative, and that gives me 40. Okay, so, you do those in your head without even realizing, but you did those. Okay, identify which property. So we're going to simplify. Well, I'm going to switch the order of these two, so I'm going to say 3 plus 5 equals 2x. Oops, not equals 2x, plus 2x. Okay, so that is the commutative property because I switched the order. And now I'm going to group these together, 3 plus 5 plus 2x. So that's going to give me 8 plus 2x, and that's all I can do with that. That's all I can simplify. I can't go anymore. And that one was the associative. There we go. Okay, because I switched them around, and then I grouped them. Likewise, for this multiplication problem, again, we don't know what A and B are, but we need to simplify this as much as possible. So if you think about this, 2 is being multiplied by A and 3 is being multiplied by B. So really, if you want to think of this, it's 2 times A times 3 times B times 6. Okay? So if I rearrange the order using the commutative property, okay, I'm going to basically say 2 times 3 times 6 times A times B. And now if I use the associative property, I'm going to group these. I'm going to group these together. So I get 2 times 3 is 6, times 6 is 36, and then I have A, B. So I use those properties. They come in handy.